Okay, so we're going to use factors to find out if a number is prime. Right, so what are the factors of 1?
1, 2.
The factors of 1, the numbers that divide into 1. What are the factors of 2?
1 and 2.
1 and 2. Factors of 3?
1, 2, 3.
Factors of 4? 1, 2, 4, yeah. Factors of 5?
1, 5.
Factors of 6?
1, 2, 3, 5.
1, 2, 3 and 6. Factors of 7?
1, 7.
Factors of 8?
1, 2, 4.
Factors of 9?
1, 3, 3.
Factors of 10?
1, 2, 5, 10.
And for now I'll just do 11 as well. We'll do 11. 1 and
1 and 11.
12?
1, 2, 6.
6 and, are you looking up?
And 4.
I forgot 4. 13?
1,
14?
1, 2, 7, 14.
15? 1?
1, 2, 3, 5, 15.
16?
1, 2, 3.
4, we've got 3, no, 4?
Oh yeah. 8.
2 and 8, 4, 4, 16 and 16. 17?
17.
18?
1, 2, 3, 4.
No? 6? 9? 18? 19?
1, 19.
20?
1, 2,
4, 5?
10.
21?
1, 3.
Oh, I've got 3. 21. 22. We won't bother with 22. 23 is only 1 and 23. Now, how do we decide? Is 1 a prime number?
Yes.
How many factors? Hold on, so what's the rule? Hold on. Well, I've got to circle the numbers that 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17 is prime, 19 is prime, 23 is the next one, and then it's 20, 29. What's happening? What's the common trait? Hold on. This one is prime. This one is prime. 2, 3 is prime. 5 is prime. 7 is prime. 11 is prime. 13 is prime. 17 is prime.
15.
What can you tell me about the factors?
There's only 2 factors.
Yeah. When you look up, a lot of you are not even looking at the board. Look up. There are only 2 factors. If there are only 2 factors, that number is prime. 2 is prime. How many factors does 4 have? 3. What about 1? It's only 1. It must have 2 factors to be a prime number. Yeah?
Is it 3 though? Is it half?
3 is a prime no, it has to be a whole numbers, no halves. 1 and so it's 1 and it's and the number itself. 1 and 3, the number itself. 1 and 5, the number itself. 1 and 7. And the next one is
1 is a prime number.
1 is not a prime number. 1 is not a prime number. How many pairs? How many factors do we need?
2.
We need 2. How many other? There's only 1. Alright. So if I asked you to write out all the prime numbers up as far as 36, we'd have to go further, wouldn't we? Alright. The next one is 23. The next one is 29. And the next one is 31 after that. 31, 33. 3 divides into 33. What's the quick way of deciding whether a number is prime or not? So we know 1 is not prime, right? Watch this. If 2 or 3 will divide into it, or 5, 2 or 3 or 5. That's a test. So we'll take a number like 31. We'll divide by 2, divide by 3, we'll divide by 5. Alright, because they divide in, they're numbers that divide into pretty much everything. We could test it with 4 as well, couldn't we? So we can test it. Does 2, does 3, does 4, because those numbers will divide into pretty much most numbers, won't they? So we'll try the number, what did I say? 31. Alright. 31 divided by 2.
No.
No, I got 31 over 2. 31 divided by 3.
No.
I get 31 over 3. 31 divided by 4.
No.
I get 31 over 4. 31 divided by 5. I get 31 over 5. Alright. So 2, 3, 4, and 5 won't divide in. Is it prime number?
Yeah.
If none of those numbers will divide in, it's a prime number. 31 is a prime number. Let's look at the number you gave to me, 33. If any one of these numbers divide in, then it's not prime. Alright, if all of these won't divide in, it's a prime number. If any one of these will divide in, it is not a prime number. Will 2 divide into 33? Will 3 divide into 33?
Yes.
4 divided into 33? 5? Alright, one of them was successful at least. So 33 is not a prime number. That's one way. That's another way of testing to see if something is prime or not. Obviously, we can go the long way and write out the factors of 33. Factors of 33 are 1, 3, 11, and 33. Okay, we can do it the long way or the short way. Did you understand that method?
Yes.
Yeah? Okay. So let's just look at an example. Write out the first 8 prime numbers. Can you remember what they are? This will help you in your homework. Let's write out prime numbers until we can write out. We'll go more than 8. We'll just write prime numbers. Alright. We'll start off with individuals and then we'll prime numbers. 1. Is 1 a prime number?
2.
2.
4. 3.
Hold on, calm down. 2 has factors 1 times 2 and nothing else. 3. 4 has 3 factors. 5 has 2 factors. 6 has
10.
4 factors. 7 is next. Next?
10.
No, 9 has 1, 3 and 9.
11.
10 has 1, 2, 5 and 10. 11 has just 1 and 11. 13. 19. The next one is 23. The next one is 21 has 1, 3, 7 and 21. 29, you're forgetting? No, 27. 3 9s to 27, that's what you're thinking of. Alright, 31, 32, 33, no, 3 will divide in. 34, 2 will divide in. 35, 5 will divide in. Remember, if 2, 3 or 5 divides in, then it's not prime. 36, 2 will divide into that. 37, 2, 3, 4 or 5 divide into 37? No, 37 is prime. 38, 2 will divide in. 39, 3 will divide in. 40, 2 will divide into that. So 41, will 2, 3, 4 or 5 divide into 41? No. 43 is the next one. 44, 2 will divide in. 45, 5 will divide in. 46, 2 will divide in. 47, 49, 7 sevens, 49. 50, 51 is next.
No, isn't 17 by 3 51?
What?
17 by 3 is 51.
17, 3 will divide into, so 51 is not right. Very good. 53, 54, 2 will divide in. 55, 5 will divide in. 56, 2 will divide into. 57, will 2 divide into that? Will 3, will 4, 5. 57, 58, 59, 3 will divide into that. 60, 3 will divide in, or 2. 61, 62, 63, 3 will divide in. 64, 65, 66, 67, 68, 69, 70, 71. Prime numbers. Now, for homework, it would be handy to have all of these prime numbers written down. Okay? Alright. For example, question 11. Write out the first 8 prime numbers. 1, 2, 3, 4, 5, 6, 7. There's the first 8 prime numbers. Explain why there is only one even prime number. This is the only even prime number. 2 will the only factors of 2 are 1 and 2. That's all you have to say.
Is there anything down further? Is there anything down further?
No.
Is the reason why 2 is the only even prime number is because it's the smallest?
Smallest number, smallest even number, yeah.
And it can't divide into
After that, every other even number is divisible by 2, isn't it? So 4 has 1, 2 and 4. 6 has 1, 2, 3, 1, 2, 3 and 6. Every other even number is not prime. Most prime numbers are odd, as you can see.
What do you have for homework then?
Right?